Hello, good morning. Hopefully everybody has had a chance to join us successfully for this webinar. If we just give us a moment, I'll start the slides and we'll kick it off. So hopefully everybody can see my screen. Welcome to today's webinar, Accelerating Utility Mapping with FARO Orbis Premium and Terrasolid software. I'm Ken Smiley, Business Development with FARO. I'll be moderating the event and hosting the Q&A later on. We'd like to have an interactive event today, so please enter any questions you have into the Q&A space, which is located on the navigation bar at the bottom of your screen. There's no need to raise your hand, just post all the questions there in the Q&A space. We'll respond to the questions at the end of the presentation. Please also participate in the polls as they appear. Your feedback is really important to us. For information about the speakers, click on the Resources tab at the bottom of your screen. We'll also share some useful links in this section, which you can click on at any time. The session is being recorded and will be available for download after the event. You'll receive an email notifying you when it's ready. So today's speakers are myself and Antti Järvenpää from Terrasolid in Finland, who you can see to my side here. A bit of an overview on the session. Urban utility documentation is often slow, labour-intensive, and prone to errors. Traditional surveying methods are essential, of course, for example, for creating coordinated ground control points, but often require significant field time for data collection and usually require specialised training. This can slow the project timelines and increase costs. Adding mobile LiDAR and advanced processing tools accelerates the data capture and improves overall efficiency of the project. In today's session, we'll cover how the Orbis, combined with Terrasolid software, offers a transformative approach to utility mapping. With mobile and stationary scanning in one device, powered by SLAM and flash technology, you can capture high-resolution, colorized point clouds quickly and accurately. Terrasolid software tools streamline the data processing and integration into engineering workflows, reducing the survey time and accelerating design cycles. Hopefully you'll see how the Orbis can capture utility data much faster than traditional methods, and with the Terrasolid software, provide a much more efficient field-to-finish solution. Now let's get started so that we've still got time for the Q&A at the end. Just before we do, we have the first audience poll. This is just to understand a little bit about how many of you are using mobile LiDAR at the moment. So as you can see, the question is, how familiar are you with mobile LiDAR and utility mapping solutions? If you could please select one of the 4 answers shown as quickly as you can, that would be great. Probably, I'd assume, some of you already have LiDAR. If so, how often do you use it in the field on your projects? Do you use it on just utility or mapping projects, or in lots and lots of different other types as well? Or, of course, maybe you don't have LiDAR just yet. I'm sure many of you have got total stations, levels, GPS systems, but we'd like to understand a little bit about the use of laser scanning in projects you may be working on. I'll just give it a few more seconds for you to reply, and we'll give the results in a moment. Okay, I think we can see the results of the poll now. Excellent, and there we have them. Oh, I've got a good spread of answers through them all. I see there's a lot of people, the highest number, 43%, haven't heard of or used one. So that's good, because we'll be explaining a little bit more about the LiDAR as we go through the presentation. Okay, so moving on, let's learn a little bit about FARO for those of you that don't know us. FARO specializes in the design, manufacture, and marketing of measuring hardware and software, many using laser or LiDAR technology. Simon Rabb and Greg Fraser founded FARO in 1981 and pioneered 3D measurement and imaging technologies in their field. Although they started out in orthopedics, by the 1990s, they'd moved into industrial and manufacturing markets, and in the 2000s began using laser trackers and laser scanning techniques. FARO solutions help to capture and measure the physical world, which we then represent in the digital world, or as it's sometimes called today, digital reality space. FARO became a public company listed on the NASDAQ in 1997, but this year became part of Ametek. Who are Ametek? In July, FARO were acquired by Ametek, who are a global manufacturer of electronic instruments and electromechanical devices used in the industrial, aerospace, and scientific markets. FARO is now part of the Ultra Precision Technologies division of Ametek. Ametek is a conglomerate with over 20,000 employees in more than 100 companies worldwide, and are a public company traded on the New York Stock Exchange. Although a very diverse business, there are synergies within the Ametek UPT division with several other companies having metrology systems or services. These are such as Creaform, Vertec, who are based in Canada, and also Taylor Hobson, based in the UK. In addition to metrology, FARO has a significant presence in the AECO, geospatial, and public safety markets with laser scanning hardware and software. And we'll look at those in a moment. FARO itself is a global company with many R&D, service centers, and sales offices across the world, as you can see. The global HQ is in Lake Mary, Florida, but we have regional headquarters in Germany and Singapore for the EMEA and APAC regions. In addition to the FARO staff of more than 1,000 people, we also have many authorized resellers and partners around the world, providing local sales and support in different countries and sub-regions. So there should always be a FARO representative in your area. FARO has lots of data collection tools in metrology, AECO, geospatial, and PSA segments. Our 3DM products, along with the other Ametek metrology businesses I mentioned a moment ago, provide highly precise measurements from the micron level upwards for many industrial and aerospace type applications. For example, this could be quality control on jigs or components in aircraft manufacturing, or reverse engineering to replace worn-out industrial parts. The laser scanning devices used in the AEC geospatial area help to measure, maintain, and analyze the built environment, and creating digital twins is a significant part of surveying applications. In addition, we have specialist workflows and software for public safety applications, such as crash scene accident investigations and crime scene analysis. However, today we're going to focus on our reality capture tools and see how these cutting-edge technologies are helping end users in various applications. On a modern job site, you need the right tool for the right job. That's why we have survey toolboxes containing different equipment for different applications. And it's the same when it comes to reality capture applications. When you need the best tool for the job, we want to have the right hardware available to us. Here are the main hardware tools available from FARO. From the left-hand side, the FARO Focus is a tripod-based laser scanner. This is for fast, high-resolution capture of buildings, industrial sites, and other natural or man-made areas. It provides very detailed point clouds for surveying measurements and documentation. In the middle is the Orbis, which is a handheld laser scanning device for mobile surveying. This can be used both outdoor or indoors, and also in very confined small spaces. It's used for inspection, maintenance, change detection, measurements, documentation, and many, many other applications. On the right-hand side is the FARO Blink, which was introduced this year. The Blink is an imaging solution combining 3D laser scanning with high-definition color imagery. It's used more in the FM space for measuring, visualization, collaboration, and reporting of spaces, particularly in industrial facilities. So the Focus excels in static, detailed, accurate long-range scanning, whereas the mobile Orbis is more flexible in capturing, documenting, and measuring on the go. And the Blink integrates imaging and laser scanning for analysis, insights, and visualization. Concentrating on the Orbis Premium handheld a little bit now. Clearly, being mobile and handheld, the data capture is very efficient, and we believe it can be up to 10 times faster than static surveying techniques. The flash scans are what makes this what we call a hybrid system. Flash scans is a technique where the mobile scanner is temporarily held static for around 15 seconds while collecting data. This produces a denser, more accurate point cloud, and it takes a higher resolution 360-degree panoramic image at the same time. This hybrid solution, part mobile, part static, increases the unit's usefulness. Where some areas may need, for instance, a little bit more detail, you can stop and collect that data in the flash scan. Processing of Orbis data can be done automatically in the cloud, and we'll talk about that a little bit later, or it can, of course, be processed locally on your PC. Looking a little bit closer to the hardware itself, the scan head contains the LiDAR and camera, plus some other electronics, and is connected to the data logger via cable. The LiDAR is a 120-meter range scanner capturing 640,000 points per second to make up the point cloud. As you can see, the Orbis has a removable handle, which can be replaced by a telescopic pole for extra height or reach into those difficult to access places. There's also a car mount and backpack accessories for the Orbis. The camera catches 360-degree panoramic images every second to create the so-called bubble views that we can access, and also to colorize the point cloud. There's a V-Lock adapter for the mobile phone or tablet to control the Orbis via the Stream app, more of which in a moment. The mobile image resolution is close to 30 megapixels or 8K resolution, but with the flash, it's enhanced to 72 megapixels. Let's have a quick look about the software side for AECO and geospatial solutions. From the left-hand side again, FARO Stream is the app which you can set up and control the hardware while you're in the field. After finishing collecting the data, you can also upload the data directly into the cloud for processing if you wish. Connect and Scene are the main desktop applications. They process, register, manage, and visualize the 3D point clouds and imagery, including uploading and syncing projects with SphereXG. SphereXG is the cloud-based platform we have, which processes, visualizes, measures, and shares not only the 3D point clouds, but also the 360 images and BIM models for streamline collaboration. As built on the far right-hand side is a software suite that we have, which allows CAD and BIM models to be created from the 3D point clouds, captured by any of the hardware solutions. From the left-hand side again, the Orbis is the data capture sensor. It's easy to learn and use, has a simple interface, and it uses guided process to make data capture simple and efficient right from the very start. In this particular case, Connect or Scene does the SLAM processing. After any required registering and cleaning of the data, we use industry standard formats to transfer the data to Terrasolid modules, where it can be analyzed, modeled, and so on, for those of you that use point clouds to create the deliverables. This is probably a good time to hand over to Ante to learn more about Terrasolid and the area heating project example they have. Plus, he has a bit of a bonus about a new software module they have regarding a new technique which many people are talking about right now. So with that, it's over to you, Ante.
Thank you, Kenneth. And Now I will share my presentation, and it should be visible right now.
Absolutely. There we go.
Yes. So thank you for the introduction and the details. Uh, Myself, I'm Antti Järvenpää from Finland. From Terrasolid, I do software support, and Terrasolid is over 30-year-old software company focusing on tools for point cloud processing and including imagery data, and also some applications for engineering design use. So about our portfolio applications, the key or the focus is on point cloud processing, those logos we see on the left-hand side with TerraScan, which is the most well-known application, and then the other tools integrate, or basically all the tools integrate with each other, but some are more used. So modular package of applications. So TerraScan is the one for processing the points, classifying, vectorizing, and that one we will see today. And the newest one, which Kenneth also mentioned in the end of the introduction part, is TerraSplat. So the special thing we will look at in the end is Gaussian splatting, which probably will bring some new ways to use handheld laser scanning data and especially the images from FARO Orbis system quite soon. Then for infrastructure design, we have also a couple of applications for planning district heating pipe systems, sewer and freshwater pipe systems, gas pipe network, and so on. And we have, thanks to that, we have been doing some demonstration with a couple of Finnish infrastructure companies, local companies, where we have been exploring the possibilities of the system in their projects. So they have been using our design applications, and now they would like to improve their workflows with point cloud data in being collected to document and get some more information. Yes, so more background of Terrasolid. Although we are today focusing with the example on Finnish use case or environment, we are a global company. On the right-hand side, we have map showing with gray color countries where our licenses are being used. So over 100 countries all over the world, globe. And as there are many applications or many software packages, there are also many fields. So the tools vary from large-scale airborne laser scanning processing to handheld laser scanning data processing and terrestrial and mobile mapping use cases. And of course, as point clouds are so versatile type of data, so we can produce many different outputs from point cloud data. There are many fields, many outputs that the Terrasolid software packages do support. So let's go to the actual content of today's presentation or webinar. So first about the agenda, brief outline what I will be talking. I will first briefly discuss about the characteristics of handheld LiDAR, why we were using handheld LiDAR, why it was good for our use case, and how it looks compared to different data from different sensors. Then focusing on the example use case, what were the outputs, what we found out, and what the partner we had realized that they could do even more that they didn't think in the beginning. And some look into the software as well, how the things work, how we can do some processing. And then the look at the Gaussian splats new visualization method, and then we will be done for the session. Go to the wrap up and questions and answers part. So first about the LiDAR data, handheld LiDAR data characteristics. So obviously, like Kenneth also mentioned, the handheld LiDAR works very well for complex environments. It could be indoor or underground environment like we see on the picture on the right-hand side. Or it could be this kind of utility site where we might have a lot of structures and maybe with tripod mounted system, we would need very many scanning positions to collect data from the different sites or all the objects we want to focus on. And also with GNSS rover, we maybe would need to spend very much time collecting points from every point of interest, but with handheld LiDAR, we can cover the area efficiently. The systems are simple to use. Here on the right-hand side, we see some documentation of our process. So there was the excavation where the pipes will be built. We used the monopod, so with that we got some extra reach and no need to go physically in the walking on the bed where the pipes will be installed. And of course, this improves the safety when we don't necessarily need to go physically touch the places where we want to measure something. And of course, with FARO Orbis, the 360 camera we have on top of the system that produces good quality photos, and that's also excellent for the Gaussian splatting input. So Gaussian splatting is technique based on image data, requires images, and can be improved with the LiDAR data. And obviously images themselves are already good for checking or getting some context of the stuff we have in the scene, but also for producing the Gaussian splats that may improve the checking the data. Then a short comparison with couple different competing methods. So probably the closest competitors for handheld LiDAR are UAV-mounted LiDAR and then there is or a tripod-mounted system. With handheld and UAV, of course, compared to the tripod system, we can capture data more quickly. We don't have to set up the system separately to every place, but we can dynamically collect data. So then we can get also better coverage. With UAV, the coverage may be easier to reach when we are working with open area. So maybe for beginning of the construction, UAV can produce data more quickly. But then if we have complex scene, the handheld system can reach places UAV can't. Tripod-mounted systems have excellent precision. So handheld and UAV are roughly on the same level. That maybe brings some needs for noise removal, noise handling. So usually we don't lose much detail compared to tripod, but maybe it gives more pressure on the software side to handle all the data well. And then with handheld systems, we can go underground, indoors. This SLAM positioning gives us the data stream still, even if we are working indoors. There are some UAV systems that are capable working indoors, but now in this in the big picture, UAV systems are not useful for those environments. And the great thing with handheld is that it's relatively small package, can be easily taken onto the field, and there is no need for huge licensing mess like with UAV. One might need to get some permissions to fly, but with handheld, where we can walk, we can basically collect data. Okay, so that was the background part, and let's go to the actual use case. So we were working with district heating construction site or company building some new pipes. So heavy, large pipes underground, heavy insulated pipes. Those need proper base. So those are not drowning in the ground or mud over time. So the use cases they were considering and we found out during the process. So obviously, before building anything, we need to have some reference for designing the infrastructure we are about to build, and that could be one use case. So here is short video clip showing some design process with point cloud data in background. Handheld maybe is not the most efficient for this because when we have no excavation yet in the area, maybe with drone system we can cover larger area more quickly. But then on the other hand, with UAV, we might not get the same capabilities when we are doing the construction. Then, of course, with the system, we can collect data for virtual site visit. So maybe we collect the images, so we could check the 360 images like Google Street View style, or if we do the Gaussian splats, then we can check how it looks on the site. So maybe if we are managing large amount of projects, and we need to get some kind of bigger picture in the office, we don't have time visiting the remote sites, we can take advantage of the data. Then one use case or one use for the data was documentation of the different project phases. So on the picture or in the picture on the right, we see comparison. So there is the bottom, and after the base gravel or crushed stone was placed on the bed where the pipes will be put, then there was new scan, and then the company doing the construction could have a proof that they have followed the specification, the requirement. So if the base doesn't hold the weight of the pipes, but those would start subsidizing in the ground later on, the construction company could have a proof that they have followed the instructions or the specification, and it's not they have done everything right. It's not their responsibility at that point, but they did the best they could. Then one aspect our partner realized during the tests was to document surprises. So if there is some old infrastructure under the ground that's not documented, maybe it's not documented at all, or maybe the documentation quality accuracy is poor. So we know that there are some pipes, but not the exact positions. So the time we dig those or dig the ground and see that, okay, there is something, we don't have to take break from the actual work, but we can efficiently, quickly scan the existing infrastructure and then continue the work. So no need to wait long time for measurements to be done. And then, of course, the documentation of the pipes we place to the ground. So on the right, again, short video clip showing this is data we captured during the tests, and we have the pipes visible there. So with Terrascan, we could digitize the pipes, classify the points, and extract the center line of the pipes to document their locations. Yes, so those were the use cases, some use cases and aspects we found during the test project, piloting the workflow. And then about the actual or the workflow, data processing workflow, how we could do things, how it could look in Terrasolid software. So first, of course, we collect data and then output it from post-processing applications, FARO Scene or FARO Connect that Kenneth mentioned in the beginning. Then usually, or we can do some alignment. It could be also done in the FARO applications. Terrasolid tools have some capabilities. So of course, the FARO applications do the SLAM alignment of the data to get the data matching well to itself. Then here one example of workflow or special tool in Terrascan to fit data to reference. So here from one area, data was measured with FARO Orbis. Then from same area, or the same area was covered with UAV system. And when we had the area covered with two systems, then the Terrascan has capability to match the data to reference by trees. So the FARO Orbis doesn't have GNSS receiver, so then, but the UAV system has, and then we could make the two datasets align, so fit the FARO Orbis data to UAV point cloud reference by pairing individual trees in the scene to each other. Yes. When the alignment is done, so data is matching reference or maybe some ground coordinate points, then some noise removal might be useful. So this is again overlapping part, but here some example picture of or from Terrascan. So on the left-hand side, we have some raw data from underground tunnel. There are some floating points, and on the right-hand side, I've applied filter to remove the floating noise points, and also to do classification to classify the floor and the tunnel walls and the ceiling. And yeah, I considered in my presentation now this classification as part of filtering as well. So for checking the data, for visualizing and visually inspecting the data, for example, when we have the roof in its own class, and if we are viewing the data from top, it can be useful because if we hide the roof or ceiling class, then we can see inside the building or a tunnel, viewing the data from top, like orthophoto type view. Yes. Then with our example project, when we are working outdoors, the next step would be ground extraction, and then we proceed to some outputs we are interested in. So it could be classification itself as the output. Maybe we do some volume calculations. So with the handheld system, if the stockpile is not too big, we can cover the pile with the system, then we could use that for volume calculations as well. Maybe we do digital terrain models or vectorized pipes like we had in the previous slide. Or maybe we would like to do layer thickness raster. So like I had in the earlier slide showing the measurement of the difference between the two layers, we could have a raster, so basically like a map of the base material thickness over the whole pipe excavation. And now I think I will show briefly the actual data application itself. Now you should be seeing Terrascan or Spadix platform running Terrascan and Terraphoto and Terramodeler applications. So I have a small sample where we collected data with FARO Orbis. The blue line, it shows the walk path or the traveling path of the system during the data collection. And in this sample, I have done some noise removal, classified the ground points, and then extracted the pipes. So this is the same data that I had visible on the slides. And in the cross section, we have the pipe vector line elements showing the place or the position of the pipes. Yes, so small construction site area. We could also view the 360 images, and here I have the images and the point cloud overlaid, so we can check the data, how the site looks, check different directions, and maybe digitize some features from here if we are interested in something, or just look how the site is, but in this Google Street View type visualization. Yes, and I will jump back to the presentation. Okay, yes. And for the visualization part and checking the environment in 3D, one new thing or upcoming thing, big thing, is Gaussian splats. And Gaussian splats is a method for visualizing 3D scenes. It takes as input images, and when the positions of image capture positions and camera calibration, so what kind of lens we have and so on, when those are solved and we have some initial points, those could be photogrammetric or taken from the LiDAR points, it creates point cloud which has some shape for each point. So those could be stretched. Those can have some transparency, and then it creates really photorealistic visualization. So the input could be images, or it could be improved with LiDAR, combining images and LiDAR. And then we get a very image-looking visualization for the parts we have visited during data collection. And to get better idea what the Gaussian splats are and how those look, I will jump to another demonstration and share screen again from the application. So now I unfortunately do not have handheld or Orbis data to show, but this is captured with UAV system. So images taken from the air from different directions around this small church. Here on the edges we see a bit how the splats look. So those can be circular or distorted ellipses. And when there are many of those overlapping with each other, then we get very much photorealistic visualization. And these could be generated from the 360 images FARO Orbis captures. And that data can be very good input for the splatting process, as it sees the objects from different directions. The splats are good when viewing the data from the directions we have visited. So if I go closer to the ground level, the ground starts to be a bit blurry because the drone didn't fly from this direction. Under the ground or under the tree canopy, we see that the grass and the gravel, those look very much blurry. But if tilting the view to show from top, we have quite nice visualization. And this can bring soon quite a lot of detail for inspecting the data afterwards. So we are not fixed to that street view navigation, but we can freely change the position and still get the image-like view of the data. So this is very much high-tech at the moment. We have tools for visualizing the splats, fresh application Terrasplat, and also our tool Terrastereo, which has been there for a while already. Those can visualize the splats, but Terrasolid, we don't have a tool for generating the splats, but that's very much developing technology at the moment, and for sure will be available soon. So to compare splats with LiDAR, for splatting Gaussian splats, we need images as input. The LiDAR point cloud can improve the result. So splats themselves, those are not accurate for measurements directly, but having LiDAR with splats can improve the accuracy. So make those measurable better and also improve the optimization process. So splats are like photogrammetric clouds in that sense that when those are generated from images, those take some processing time. So usually LiDAR point cloud generation is faster because there are direct measurements those points are based on. But the big thing with splats is the visual quality. So we can get very nice looking visualization and the dynamic 3D navigation possibility with the splats. As the splats are a bit noisy for classification, so detecting what is ground, what is tree, what is building, splats don't work as nicely compared to LiDAR. So probably mixing these two methods is the best way working with the new technology. So to summarize, wrap up, with FARO Orbis, we get very versatile data. So there were many different use cases, and also we figured out different or more use cases during the pilot project. With our tools, we can get the information out of the data. So vectorize stuff from the point cloud, classify, and so on. And the point cloud data, it can be also that when we collect the data, we don't know all the results or the measurements we are going to create from the data. So maybe when we archive the point cloud, someday later we realize that actually we would need this information, and maybe we find it from the point cloud. Yes. Do Kenneth have something to continue with?
Yes, yeah. Thanks very much, Antti. It's fascinating. I like the way that we have the variety of applications that you can handle with both the Orbis and the Terrasolid software. So we had the utility mapping, and then we had forestry, and also the ability to use the splats. If I think we can come back to my screen now, if you just hold on a moment. So what we'd like to do now is we'd like to go into the second poll. So before the Q&A, we'd like to have a second audience poll. The question is, as you can see, if mobile LiDAR and smart processing cut your utility mapping time by 10 times, how would you use the time saved? Again, please select one of the 4 answers shown on the screen while it's there. I think the productivity increase from mobile LiDAR can allow you to take on more jobs or more projects, or reduce the costs on the ones that you are working on. It also helps to solve staffing issues. And many of us know that hiring staff in our industry can be difficult. So a much more efficient and productive sensor is pretty useful. So just to remind you, productivity is the amount of work you can get done in a certain amount of time. Efficiency measures how well you can use resources to get a task done. So hopefully you can see that by using the Orbis and the Terrasolid modules that you can actually gain in both counts. I'll just leave it for a couple of more seconds to reply. and they will give the results in a moment. I know we're heading up to the top of the hour, so we won't be too long. Just if we can finish this poll, that would be great. Okay, let's see the results of the poll. Okay, time saved. And the highest one there is, yeah, reduce operational costs. Of course, that's the great thing about it. As I say, if you can be more efficient, let's say with a unit that can do both work indoors and work outdoors, you're actually maximizing the effective use of your resources. So that's a great one. Okay, so just to get near the end then, what we're going to do is we're going to jump into the Q&A section. So if you've got any questions on the Q&A side, remember to put the questions in at the bottom on the Q&A on the navigation bar. One thing that people might be possibly asking is a few of the technical details. What's the IP rating, for instance, of the Orbis? It's IP54, so you can go out and use it pretty well in all weathers, including some very light rain, although you probably wouldn't want to do that yourself. Battery life, the batteries are valid for 2 hours. We normally ship the unit with 2 batteries, so you've got a minimum of 4 hours working time with the system. Don't worry about data storage. The Orbis system has a 512 gigabyte memory, which is equivalent to about 50 hours of data scanning. And when you think about the amount of time you're actually scanning, then 50 hours is enough. And of course, then when you go back to the office, you can download the memory from the system. Specific export formats. So from Connect and Scene, we can export in E57, LES, LAZ, PLY, and text. And the flash scans, which I mentioned earlier on, the more dense, more higher resolution scans can be exported as E57s as well. And that is including the images. If there are no more questions, perhaps we can just, at the very end, move on to the final poll. So this is the last audience poll to let us know what we can do for you after the webinar. As you can see, the question is, what can FARO or Terrasolid do for you next? Hopefully, you'll have seen something in the hardware or software that's of interest to you and your company or department that could make a big difference to your work in utility surveys and other areas, any projects that you might use on a regular basis. So if you could fill in this final poll, we'll be wrapping up very shortly, hopefully at the top of the hour, which we're just hitting on now. Okay, let's see what the results of the poll are now. Okay, so we've got a tie. Excellent. We've got a tie. More information, nothing at this time. Well, hopefully, if there's nothing at this time, that means that the majority of you hopefully are already using LiDAR and you're seeing the benefits of the speed, the accuracy, the quality of the data that you or your clients can use. But for those of you that have asked for more information, myself and Antti will make sure that we provide you with more information. So with that, I'd like to say thank you to Antti from Terrasolid for joining me and presenting in the webinar today. I'd also like to thank our friends at ConnectMe for setting up the webinar. This is part of their Asset Mapping Events webinar series. And of course, we'd like to thank you all for attending and spending your valuable time with us. Remember that you will be sent a link to watch the whole webinar in full at your leisure later on. And don't hesitate to contact FARO or Terrasolid if you've got any further questions or to follow up on any of the ones that we didn't have time to answer. So once again, thank you and goodbye.
Thanks a lot.